So this is the review for the Unit 9 material, sequences and series. And so if you guys look at your formula sheet, we're going to be using these equations right here. So starting here, this is a arithmetic sequence. Excuse me, this shouldn't say sequence. This is a series. And here, whenever you see the word sum, that should tell you to use this equation right here. So these are giving you sums. And this is arithmetic series. So we want to use this one right here. So n over 2, a1 plus an. So first step here is to find our equation, and we've done this already in the reviews in class. So here, my pattern is adding 3. So my original equation for what's happening is my recursive is a1 plus dn minus 1. So this one you need to remember, okay? So this is not on the over here, so an is equal to a1 plus dn minus 1. Okay, so this one, remember it. So first step, so a1 is this right here, the first number. D is just the pattern, so 3 n minus 1, and remember we got to distribute, so this is going to be 3 plus 3n minus 3, which here the 3's end up canceling, so this is my equation. Okay, so that I can find my numbers. So now that I have this one, my recursive, I can use the ones that they give me here. Okay, so here they wanted to know up to n equals 8. So that's what goes right here for n. So this is going to be 8 over 2. My a1, well, I should know it from the equation, so it's just 3. Plus an is just going to, this is where it comes into using this equation. So a8 is going to be 3 times 8. So it's 24, so plus 24. And from here, guys, you just do some math. So 8 divided by 2 is 4. 3 plus 24 is 27. So this is 4 times 27, which equals 108. Okay. So we're going to move on here. I'm not going to do both of these here, but we'll do up to n equals 6. And this is a geometric sequence, but we're finding the sum again. So that tells me to use this right here, sum, but now for a geometric. Okay, so my equation that I eventually want to use is a1 times 1 minus r over n divided by 1 minus r. So let's find the pattern here. So from negative 3 to negative 9, this is a times 3 times 3. So my r is equal to 3. And my original equation, so this one's not on here, my recursive for a geometric is a1 times r to the n minus 1 power. So this is a1, negative 3, r, 3, n minus 1. So we're going to use this right now in a little bit. So Sn is equal to a1, 1 minus r to the n over 1 minus r. So a1 is negative 3. 1 minus r, which is 3 to the n power. So here, n equals 6. over 1 minus 3. Okay, so this would be negative 3 over negative 2, and then 3 to the 6th power is going to be 1 minus 729. Negative 10, excuse me, 1092. So numbers will get big for this one. So on a geometric one, expect to use a calculator. Okay, last one here. So here I'm asked to give the sum, but it doesn't tell me where it stops. So I'm going to assume it keeps going on forever, which makes it infinite. So I'm going to use this equation right here. And we're going to see the pattern should be for geometric, so it's going to be multiplying. So if I look at this here, to get from 4 to negative 2, I have to divide by 2. I have to divide by 2. That means my r is 1/2, okay? And that's the first step here. If it's converging, the r has to be smaller than 1. And here, 1/2 is smaller than 1. So we can use the equation they give us. Okay, so a1 is negative 4. 1 minus r, which is 1/2. So this is negative 4. 1 minus 1/2 is just 1/2. So I'll do keep, flip, and change. So times 2 over 1, which is equal to negative 8. Okay, so this is what you need to remember, guys, for chapter 9. And just look for the next video.